Let's review some of the ways you can get the most out of GVERSE GeoGraphix Zone Manager. Data analytics is becoming a big part of our daily workflows. So today we're going to take a look at how data analytics tools can be integrated with GeoGraphix. In this brief 20-minute presentation, we'll review current Zone Manager functionality and take a look at a few new features that will be available in next month's release. But first, a short review of zones and attributes in GeoGraphix. Zone Manager is an application that lets you define zones in the subsurface and assign attributes, rock properties, to those zones. Zone attributes can be visualized as contour maps in the software and used in other ways. Now, a zone is typically defined as a facies change within the subsurface, and this facies change is often identified using formation tops picked in your project wells. Zones can also be defined as an offset above or below formation picks, or defined as the measured depth between a formation pick and the TD of the well. If you have a lot of horizontal wells, and most of us do, this might be the best way to define a zone in GeoGraphix. Now, after defining a zone, we need to assign attributes to that zone. An attribute is some property of the subsurface or well that is associated with the zone. Not all well data that you import into GeoGraphix is available in common vendor well formats such as IHS 297 and Drilling Info. So, you can think of Zone Manager as an application to import unstructured data into the system. Think of Zone Manager as a giant Excel spreadsheet with many ways to import subsurface properties into GeoGraphix and associate them with your wells and zones. Now, it's worth noting that in order to define a zone for a particular well, the formation picks used to define the zone must be present. If they're not present, the zone can't be defined for the well. Rapidly calculating pseudotops or interpolated tops from isomap surfaces, sourced either from existing picks or from geomodeled surfaces created in GeoGraphic's Geo Modeling, is our next topic. So let me demonstrate a new feature that lets you create interpolated or pseudotops from the subsurface map layer. The measured depths of the interpolated picks are calculated as the intersection of the subsurface layer and the wellbore. This feature is new in our version 2019.3 release out at the end of next month. I've selected a zone I've named Niobrara Test in Zone Manager and defined it as the top of the Niobrara formation to the TD of the well. Now, open the Create Interpolated Tops dialog from the Import menu. To create pseudotops, you simply choose an isomap layer in your area of interest, and then specify the name of the formation and the source or author of the interpolated tops. By default, the source name is interp, but you can choose an existing source or choose whether you would like to override existing picks with that source. You can also apply a well-based filter so that interpolated tops are calculated for only a filtered list of wells. At the end of the operation, a log is generated that gives the reasons why tops for certain wells could not be interpolated successfully. Some common reasons include the TD of the well is shallower than the depth of the subsurface layer, no TD exists for the well, or the well lies in a region where the isomap grid cell value is null or not defined. A well-based filter can be created for wells where interpolation was unsuccessful. As you can see, interpolated tops have been generated to define the zones and are also added to wellbase as formation picks. This new feature enhances several common workflows, such as calculating geoprognosis reports for proposed wells, defining valid zones for more wells in your map area, and assigning attributes to zones using the ISOMAP import feature. Let's review all three scenarios. Calculating geoprognosis reports for proposed wells is one of the most common workflows in upstream oil and gas. The interpolated tops feature makes it very easy to generate a geoprognosis quickly using ISOMAP layers. Simply create a well-based filter for your proposed wells, select the subsurface layer, and generate the geoprognosis tops. Generating pseudotops this way also makes it possible to define zones for many more wells than would normally be possible. For Zone Manager to define the top and base measured depth for a zone in a well, the picks for the relevant formations must be present. It's now possible to generate these picks quickly for a very large number of wells without having to manually pick tops from well logs. A very efficient way to import subsurface attributes in Zone Manager is to import them directly from ISOMAP layers. Let's say I have a contour map of temperature data in the Niobrara Formation, and I want to add these data to my Niobrara test zone. Select the ISOMAP Import dialog from the Import menu in Zone Manager. Select the ISOMAP layer, zone name, the attribute, and any well-based filter you'd like to use. Zone Manager will use the ISOMAP grid values to interpolate temperature values for the wells. However, if valid zones are not defined for certain wells, no temperature data can be added for those wells. Here, we can see that the bottom hole temperatures were added to the Niobrara test zone after completion of the import process. The new interpolated tops generator greatly expands the amount of temperature data that can be added to the wells and zones, from only a few wells that have existing Niobrara tops to all wells that have newly generated Niobrara tops. Now let's look at how we can analyze zone attributes in TIBCO Spotfire. First, I'll demonstrate how to connect the SAP SQL Anywhere database in Geographics to TIBCO's Spotfire data analytics package. Spotfire is widely used in our industry for visualization and analysis of well and production data. First, we'll log into Spotfire. Spotfire will take a few seconds to appear. Now navigate to Files and Data using the plus icon on the Spotfire toolbar. Select Other, and then Load Data with ODBC. ODBC stands for Open Database Connectivity. It's a worldwide standard that specifies how software applications connect to relational databases. ODBC data source names, or DSNs, are created using the ODBC Manager application installed on all Windows machines. The information for these data source names are stored in the Windows registry. Every time a Geographics project is activated in Project Explorer, an ODBC DSN entry is created, and the previous active project's ODBC entry is destroyed. It's this ODBC entry that we will use to connect to Spotfire. Now note that an ODBC registry entry is always located on the client's machine, not on the server. The DSN specifies how software applications on your machine connect to relational databases on other machines. To browse Geographics tables in Spotfire, select the ODBC data provider from the list box and then configure. Make sure you select GXDB as the DSN, the data source name. And then specify DBA as the username and SQL as the password. Once the connection is made, it's simple to navigate to any of the public petroleum data model tables in Geographics. Now you can use these tables in your Spotfire analysis. If you would like to connect to the Geographics database from a machine that does not have Geographics installed, you will need to install SAP's SQL Anywhere database drivers on your machine and then create an ODBC data source name using the Windows ODBC Manager. The SQL Anywhere drivers are available from SAP's website, or you can call GVERSE GeoGraphix customer support. Now let's take a look at how we can analyze zone attribute data from Geographics in Spotfire. One common request is to cross-plot zone attribute data and do a multi-regression analysis comparing predicted variables with a response variable. The response variable may be something like initial oil production from IP vendor data, and the predictor variables may be zone attributes such as V-shell, vitrinite reflectance, porosity, or water saturation. In the 2019.3 release of Geographics, we will be shipping built-in Spotfire connectors that will automate the connection process to Spotfire, as well as deliver a number of pre-made Spotfire templates for performing various analyses. However, if you're on an older release of Geographics, don't worry, it's still possible to do a zone attribute analysis in Spotfire relatively easily. The key is to create a query that joins zone attributes and scout ticket data from the Geographics database and pivot that data so that every zone attribute becomes a column in the query. Think of it as creating a spreadsheet of data in the format here. In addition to the scout ticket data, we also have the zones for the wells and the attributes as columns in the spreadsheet. Many of you are probably already doing something like this in Excel spreadsheets and analyzing your well data in Spotfire or Power BI. However, SAP SQL Anywhere is a very powerful relational database with a full set of SQL querying functions. Using the power of SQL, we can import millions of zone and attribute records from Geographics into Spotfire for analysis. So let's specify a query to bring these data into Spotfire in a format that's ready-made for regression analysis. First, the query. Now don't worry, it's not as complex as it seems, and we will make it available on our support website so that folks can paste it into Spotfire and do their attribute analyses there. This query simply joins scout ticket, zone, and attribute data from Geographics and pivots these data so that each zone attribute becomes a column in the query. It's worth noting that while Spotfire is an extremely powerful data analysis and visualization tool, it doesn't have the full power of a SQL database for data manipulation. And the public petroleum data model database tables that most G&G platforms implement don't lend themselves well to producing the denormalized data formats required by analytics platforms such as Spotfire, Power BI, and Tableau. Moving forward, the focus of Geographics Analytics will be to build additional tables, views, and materialized views into the Geographics database that enhance analysis of big data on these platforms. So, let's paste the query into Spotfire and let Spotfire load the data in a tabular format suitable for further analysis. After loading the zone attribute data using the query, I'll add a map chart as a visualization in Spotfire to show where my wells are located in the project area. Note that I included the well's surface latitude and longitude values in the query so that I can display the wells on the map. Now from here, I'll add 2D and 3D scatter plots to perform regression analyses on various zone attributes. First, I'll correlate water saturation against porosity on a 2D scatter plot. Let's filter the data to just include data from the Niobrara zone. Now let's add a 3D crossplot. Here, I'll correlate saturated pay, porosity, and water saturation. In this rather contrived example, we see that water saturation is fairly well correlated with porosity. No surprise there. However, Spotfire contains advanced analytics tools to perform multi-regression analysis on many variables. For a simple analysis, we can use the data relationship feature in Spotfire. In this case, we perform a linear regression between porosity and saturated pay and porosity and water saturation. We can see that there's a slightly better correlation between saturated pay and porosity than water saturation and porosity. For multivariate regressions, we can use Spotfire's regression modeling feature. One attribute is chosen as the response column, in this case the gross thickness of the zone, and saturated pay, porosity, and water saturation are selected as the predictor columns. Again, it's no surprise that saturated pay correlates most strongly with the thickness of the zone. Now let's turn our attention to another common request. How do we associate well data, often vendor data such as IPs, production tests, DSTs, cores, perfs, and completions, with the correct zone in the subsurface? The Calculate Formations feature in WellBase and the Zone Scan Calculator in Zone Manager both can help, and with the addition of the Generate Interpolated Tops feature, they can be even more useful in many workflows. But due to the huge amount of data now available in the shale plays, attempting to create zone attributes this way has performance limitations. For instance, these perfs may lie entirely within the zone or only partially within the zone, or perhaps they don't lie in any zone at all. Generally, we want to use analytics tools to analyze only well and production data within a certain zone of interest. In order to use analytics tools effectively, it is absolutely necessary that every piece of vendor well data imported into the system is identified with the zone or zones it lies within. After a lot of thought, we've decided to bring out the big hammer, and we're going to create new database tables in Geographics that tag well data in the Geographics database with the zone it's located in. Well data is generally defined over an interval, and we can use that interval to determine whether the data lies partially or totally within the zone of interest. Here's an example using DSTs. Notice that every DST record contains the zone the DST lies in and includes the top and base of the zone and the length, interval amount, of the test lying within the zone. To generate this information within Zone Manager, simply use the new Update Zone Data button in the Edit Zones and Attributes dialog. Just as the Calc XYZ function defines the top and base of the zone in the well using the zone definition, using the new Update Zone Data feature identifies all well data, perfs, DSTs, completions, cores, that lie within the Niobrara test zone. Now it's easy to start analyzing well and production data by the zone it lies within. For instance, we've added a new feature to create conditional pies using the zone the data is located in as part of the query. Here, we just want to create pies for wells that have gamma ray logs within the Codel zone.